All right, so good evening, everybody. My name is Francisco, and today I would like to explain to you guys my mathematics for economics 2 final exam. All right, so here's question one. Question one, we are asked to investigate the behavior of price in a market with the demand and supply functions mentioned as follow. Then we have dt here as the demand, st as the supply, and then pt here shows the price at time t respectively. Now, by assuming market clearing in each period, dt is equals to st and p0 is equals to at. Now, the first question is to determine the difference equation that represents the relation between pt and pt minus 1, and then we're asked to interpret the equation. And then we're asked to solve the equation obtained in part A, and last but not least is to investigate the stability of the equilibrium price in the market and to interpret the results. All right, so question one. Here I wrote down the information necessary to answer the question. Here we have dt, which is the demand function at time t. dt is equals to 9t minus 0.8 pt, and then st, the supply, is equals to negative 6 plus 0.2 pt minus 1. And then we also have the information about market and clearing each period. dt is equals to st, and then p, when time is 0, is equals to 8t. Now, the first step is to equate dt is equals to st. And then we have here 9t minus 0.8 pt is equals to negative 6 plus 0.2 pt minus 1. And then making pt as a subject, you should have this pt is equals to negative 0.95 pt minus 1 plus 120. Now we can actually change it into the form of pt plus 1 for further calculations, but here I already mentioned here I already satisfied the first question, which is the relation between pt and pt minus 1. So pt is equals to negative 0.25 pt minus 1 plus 120. Now to interpret the equation, so we know that we derive this equation from equating dt is equals to st, which is essentially the equilibrium. So what this equation actually shows is that it's the changes of the equilibrium prices as time passes or throughout the time. Now, the second step is to create the general solution to solve the equation previously. So, forming the general solution, we have pt is equals to pt power of h plus pe. I forget to put pe here. And then, first of all, the easiest one to find pe. Pe is essentially b over 1 minus a. What is B? What is A? B is 120 and A is negative 0.25. And then, so when we try to find PE, we will have the number 96 exactly. Now, calculating the PTH, the homogeneous equation, we know that from this equation, we can directly convert, when it's a homogeneous equation, we can directly convert into A, or basically any variable, constant variable. I put a times negative 0.35 to the power of t here. You see, as I mentioned here, homogeneous. Now, equating back to the original equation here, we have pt, which is pt is equals to pt, the homogeneous equation here, which is this. And then I should plus pe here, but forgot. So here we add 96 from pe. So we have pt is equals to a times negative 0.35 to the power of t plus 96. Now we need to solve A, and how do we found A? Right here, pt is equals to A times negative 0.85 to the power of t plus 96. And then we have the information previously that when time is equals to 0, p is 80. So then we just substitute t is equals to 0, p0, t0, then substitute p0 with 80, and then as we know, negative 0.25 times to the power of 0 will be 1 exactly. So 80 is equals to a plus 96, and then we put 96 to the left, we will have a is equals to negative 16. Now the complete equation for pt is that pt is equals to negative 16 times negative 0.25 to the power of t plus 96. Now for the last part, we are asked to check the stability of the equation. Now, for a linear difference equation, the objective of the stability is that when the absolute value of A is less than 1, the equation is said to be stable. So in this case here, from our first question, negative 0.25 is essentially A, and then 120 is B. So checking the stability, we only need A. So the absolute of negative 0.25 is 0.25, which is less than 1. So to interpret this, basically the equilibrium price is said to be stable as A is less than 1. Now moving on to question number 2. Here we have the aggregate output YT, given by YT is equal to the square root of KT, where KT is the capital stock at time T. And then capital stock have their own equation which evolves over time, which is mentioned here. 1 minus delta. Delta here represents the capital depreciation, and IT here represents the investment at time T. Now, the economy saves at a constant proportion S of output every period. Thus, savings ST is given by the formula ST is equals to S, the saving proportions, times YT, the aggregate output. Now, imposing the equilibrium conditions, ST is equals to IT, and setting delta is equals to 0.1, and then S, the saving proportion, 0.3. Now, there are 4 questions here. First of all, we're asked to derive the nonlinear difference equation, and then B is to find the equilibrium solutions for the nonlinear difference equation, and then C is to investigate the stability, and then D is to give the interpretation of the results obtained in part C. Again, I always write down the information necessary first, so that it won't miss out. Here we have KT, the equation for KT that evolves over time. We also have YT, the aggregate output, and then KT, the capital stock. Delta here is 0.1, the capital depreciation. IT is investment at time T. Big ST is the saving at time T. And then small s, which is the constant saving proportion, 0.3. And then we also have ST is equals to SYT, and then ST is equals to AT. Now, first of all, deriving the nonlinear difference equation. We have the equation here that KT is equals to 1 minus delta KT plus IT. And then we know that ST is equals to IT, right? So yeah, we also have here ST is equals to SYT. That means we can equate IT with ST, which also equates to SYT. And then here YT, we also have the information that YT is equals to square root of KT. That means we just substitute YT with that. So we will have ST is equals to small s times square root of KT. That means that we can substitute IT with this. Now, substituting back to the original equation, we will have KT plus 1 is equals to 1 minus delta KT plus S to the times square root of KT. We also know delta and S here, 0.1 and 0.3 respectively. We will have KT plus 1 is equals to 0.9 KT plus 0.3 square root of KT. All right, next is to find the equilibrium solution. So essentially, when you're trying to find the equilibrium solution, all you need to do is to replace all of KT to KE, the equilibrium. See, what I did here is that KE is equal to 0.9 KE plus 0.3 times square root of KE. Now here, KE will be counted as a unit. Therefore, I move KE to the right to have negative 0.1 KE here. And then I move the square to become power of half. Now we share KE, both KE here in common. That means we can take KE out from the equation. We will have, when we factorize it, we will have KE times negative 0.1 plus 0.3 KE to the power negative half. This equals to 0, right? So what does it mean? That means it has 2 solutions. One is from KE is equal to 0, and the other one is the remaining part here is equal to 0. Now KE is equal to 0 is certain, and then we're going to solve for the the remaining part, which is negative 0.1 plus 0.3 KE to the power negative half is equal to 0. Now, with simple algebra, you should find that KE will be equals to 9. So what does it mean? That means we have 2 equilibrium solutions here. We have when KE is equal to 0 and when KE is equals to 9. All right. Moving on. Now, to investigate the stability. So how do you investigate the stability of the equation? To found that is that you have to derive the function itself at the equilibrium level, and the value of that needs to be less than 0. So here I wrote f prime at ye is less than 0, and then we know that ye we have two solutions at ye, which is 0 and 9. First of all, we differentiate f to f prime here. So with respect to ke, so it will be 0.9 plus 0.15 ke to the power of negative half. And then we substitute 0 with 9 to each equation, the f prime. So here, f0, we will have no solutions, while f9, we will have 0.95. So what does 0.95 actually means? Now, for testing the stability, ye is said to be stable if and only if the absolute of f prime at ye is less than 1. Therefore, 0.95 is less than 1. Therefore, when ke is equals to 9, the equilibrium point is said to be stable. That is, in the long run, the capital stock will reach the point at 9. Now, going on to the third question. Here we have a few equations. First of all, we're asked that can a government run a persistent budget deficit? Can a national debt grow forever without bankrupting the nation? Here we have dytr, dy and r. dt here represents the amount of debt at year t, yt represents the national income at year t, and then r is the interest rate on debt per year. Also have the information that when t is equal to 0, d will be 0, and when t is equal to 0, y is equal to 1. Now here, the nation is said to be bankrupt when the equation satisfies that r dt over yt bigger than or equals to 1 at some year. Now suppose that the time path of income is given by y dot is equals to gyt, and time path of debt is given by d dot is equals to byt. Now let's pretend you're the government. You are informed that R, the interest rate is 5%, and B is 0.1. Now we're asked to make a target on the income growth G to avoid your country from bankruptcy. Here we're given some few hints here. First, we got to solve the differential equations by y dot and d dot. Again, as I did previously from previous questions, also I always write the necessary information first, so I won't miss out any of it. We have time path of debt, we have time path of income, and then bankruptcy is defined as RDT over YT bigger than or equals to 1. And then when time is 0, D is 0, and when time is 0, Y is equals to 1. We also have interest rate, and the B is 0.1. Now, to approach this question, as given by the hint, we're asked to solve for Y dot and D dot. First of all, let's investigate y dot and gyt. From this, we know that this is a homogeneous equation. Y dot is equal to gyt is a homogeneous equation. So directly, again, we can convert the equation into yt is equals to ae to the power of gt. Now, we also have the information that when time is equal to 0, y is equals to 1. So here, we substitute t to 0, so a to the power of g times 0 will be 1, and then y0 is essentially 1, so a is equals to 1. Therefore, leaving the equation yt is equals to e to the power of gt. Now, to solve for d dot, why can't we just convert this into the same one? Because d dot has different variables in it, so it's not a homogeneous equation. But then here we have byt, and then we have yt, which is e to the power of gt, and then we just substitute that to the equation, which will leaves us with d dot is equals to b to the power of gt. Now, what does d dot actually means? It means the difference equation of d. So we can say that d dot is dd over dt, which is equals to b times e to the power of gt. Now, I put dt to the right so that we can have the function of dt. Now, to get the function of dt from a derivative, we need to integrate, right? So if you integrate one side, you need to integrate the other side. So integrate both sides of dd and be. And then I put here the limit 0 to s. S is just basically another variable that I put so that it won't confuse us if we use variables such as t, right? So in the integral of dd will be, with the limit of 0 to s, will be ds minus d0. And then the integration of b to the power of gt with limit 0 to s will have that b over g times e to the power of gt minus bg, b over g. Now, we also have the information that when time is equal to 0, d is 0. So then we just remove d0 here, and therefore we have ds is equals to this equation right here. Basically, this is just taking out bg from each system. So yeah, factorizing it, we will have this number, this system, sorry. So yeah, basically dt is equals to b over g times e to the power of gt minus 1. All right, we have yt, we have dt. What's the next step? Now, since we have both, we're going to substitute back to the original, to the equation where it states that nation is going to be bankrupt, which is rdt over yt. We substitute that dt and yt here. And then, again, to save time, just going to simplify the equation to the last part here, which is, so we will have rb over g times 1 minus e to the power of negative gt. Now, from this equation, I can say that the time path will converge to rb over g. Now, if you ask me what happens to 1 minus e to the power of negative gt, is that no matter how big the number of t or g, the result will always be 1. Therefore, leaving rb over g times 1, which is essentially rb over g. Now, for a country to become not bankrupt, r dt over yt needs to be less than 1. So then let's just substitute rb per g into less than 1. Here, as I said before, based on the stable state, rb per g is less than 1. I move g to the right with cross multiplication, and then since we have the information of r and b, we just substitute to the equation here. We have 5%, which is 0.05, and then b is 0.1, which leaves us this. In other words, g is bigger than 0.005. Now, how do you interpret the question? This means that for the country to not be bankrupt, g must be bigger than 0.005. Or if you don't have the numbers like this one here, you can say that the debt growth, which is RB, must not exceed or equals to their income growth G. That is it. Moving on to the last questions, which is to explain the concept of stability of equilibrium point in a nonlinear first order differential equation. And then we also asked to provide an example of the application in economics, business, or finance. All right, so I'm going to explain the first question first. So basically, in a nonlinear first order differential equation, stability is defined when the f prime at ye is less than 0. Basically, the analysis tells us about the convergence property of the differential equation itself. Now, a state point is stable if the differential system converges to that point. So the graph should go to that particular equilibrium point. Otherwise, it is said to be unstable. This implies that when a particular ye is less than 0, the long-run graph will reach the point of equilibrium. Now, the application towards economics is that I'm going to use the implication for economic growth. There are some few assumptions. We have y is equal to f with k and l as a variable. Here, we don't have the exact equations as it can be super random. And then we know that K is the aggregate capital stock and L is the total labor. Here we have small k, which is equals to K per L, which is capital to labor ratio. And then, as we know, the economy's output can be either consumed or be saved. Therefore, K increases by the amount of investment, which equals to output saved, right? So investment is equal to saving. So yeah, here. then we also assume that we have a constant savings rate. So this leaves us with S here, the savings rate, and then K is equal to S times Y. Now, K dot is basically the change in capital stock. Heads up that this equation has been thoroughly explained. So after substitution and so on and so forth, we get the equation here. K dot is equals to S times Y over L minus NK. Right, and then since some few assumptions says that Y is equals to big Y per L, and using F is equals to FK, this becomes K dot is equals to this. Now, essentially, just for the implications towards economics, basically from this equation, we can draw the graph, and then from the graph, it shows that when K is equals to K asterisk, a point along the graph, it proves that the stability is steady state of the equilibrium. So basically, it's similar in terms of these ways of finding the stability, is that the derivative will prove that the equation, not will prove, it will determine whether the equation is in a steady state or not. Now, this nonlinear differential equation for the capital labor ratio describes the growth of the economy of the model. Now, because labor force is assumed to grow at the rate of N, the model predicts that the convergence, basically, of the economy is leading towards steady state growth path on which output, capital, and the labor force all grow at the rate of N. All right, so that is it for my explanation. Thank you very much.